Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Shah. I am lecturer in Department of Technology, Sarad University of Science and Information Technology, Peshawar. As I am teaching in the subject Design of Hydraulic Structure, today is your lecture number 24. In lecture number 24, we will study about canal outlets or canal modules. So, what is canal module or canal outlets? A canal outlet or module is a small structure built across the head of the water course so as to connect it with a minor or a distributed channel, and it acts as an connecting link between the system manager and the farmers. What are requirements of a good module? It should be fit well to the decided principles of water distribution, and it should be simple in construction. Also, it should work efficiently with a small working head. It should be cheaper. Also, it should be sufficiently strong with no moving parts, thus avoiding periodic maintenance. And it should have such as to avoid interference by cultivators. It should draw its fair share of shade. So these are the requirements of a good module which should be present in order to get the maximum discharge from the distributaries. Next is types of modules or outlets. There are several types of modules. The first one is a non-modular module. And non-modular modules are those through which the discharge depends upon the head difference between the distributor and the water course. The common examples are the open sluice and round pipe outlet. As you can see in the figure, this is the bed of the distributory, and this is the distributory channel. This is the bed of water course. We have to transfer water from here to there. So for this purpose, we have provided a round pipe through which the water moves from here to here. For this, we have to give a working head which causes flow. As you can see in the figure, in this case, this is the total working head which is provided in order to in order to move the water from the distributory channel to the water course. So water enters from here, and because of this working head, water enters in the pipe and moves into this water course. Lowering of the bed of the water course will draw extra discharge. Thus, equitable distribution of discharge may not be possible. So if you lower the bed of this water course, then you can get the extra discharge. This is the bed of the water course. If you lower this, you will get the extra discharge from the distributory channel. The next type is the semi-modules or flexible modules. Due to the construction, a supercritical velocity is ensured in the throat and thereby allowing the formation of a jump in the expanding flumes. This formation of hydraulic jump makes the outlet discharge independent of the water level in water course, and thus making it a semi-module. Semi-modules or flexible modules are those through which the discharge is independent of the water level of the water course but depends only upon the water level of the distributary so long as a minimum working head is available. Examples are the pipe outlet, open flume type, etc. This is the example of semi-module. We have a Venturi flume. This is designed by Kennedy in 1906 in Punjab. This is the full supply level of the distributary. This is the bell mouth entry through which the water enters in here, moving to the throat and then expanding in the pipe, and then through this section the water enters the water course. This is the total head, working head HL. This is the total working head through which the water moves in this whole section and entering the water from the distributor to the water course. Also, there is an vent pipe is provided in order to remove the entrapped air from this pipe, so that the water can easily move in this expanding pipe. The next type is the rigid modules or modular outlet. Rigid modules or modular outlets are those through which discharge is constant and fixed within limits, irrespective of the fluctuation of the water level of either the distributary or of the water course or both. An example is a Gibbs module. This is the Gibbs module. This is the distributary channel. In this, a head wall is constructed, and within this head wall, a inlet pipe is provided. The water enters in this pipe and moves through this pipe in the spiral rising pipe, and then move to the water bed course, bed of the water course. So as you can see in the figure, this is the section of the pipe. This is the full supply level of water. Clear? The water enters through this pipe. This is the shutter rod through which the water is supplied in this pipe. The water moves in this pipe with a high velocity, then moves in this spiral rising pipe, and then it moves to the water course. So this is known as the Gibbs module. This is the end of our today's lecture.